All right, good morning again, everybody. So this next section on VMD, or Visual Molecular Dynamics, is going to be kind of a short one. VMD is it's pretty light on VR. It's mostly, kind of a desktop tool for molecular visualization and simulation. But I think it's still a good one to have kind of in your toolbox. So we'll cover things pretty quickly with VMD. But I want to, like I say, give you a little demo and show you its current state. We're actually in the process of enhancing it a little bit right now, myself and the main developer of VMD. So it'll be improving in the near future. So we'll cover a little bit about VMD. So VMD actually was based off, an application that was started in 1992 at the National Center for Supercomputing Applications by, missed a quote mark there, by Mike Crow, who was in the visualization group there with myself back in the early 90s. And we started a small VR lab at the time. It was before the cave was actually invented, or at least released as an invention. And we had some really old-fashioned virtual reality equipment. And Mike wrote this program called VR Chem. And so it was basically just, a molecule loader, and you had this head-mounted display type device, and you looked around it. He started collaborating with a member of the theoretical and computational biophysics group, and a student of Klaus Scholten, who's the head of that group, and they started working together. And then a couple years later, Mike left NCSA, and the person he was collaborating with said, "Okay, now we have kind of a baseline. Let's start over." And so he started over with VMD, and a lot of this is actually covered in this They have this long history document about VMD. It's a very popular thing, so a lot of people know about it and use it. So Professor Scholten, one of the things that he kind of found, and you'll find a lot of people who work in molecules and crystallography really love to have stereo. They really want to be able to see, more than just kind of a mishmash of things that are all flat together. They want to see the 3D structure of the molecules. So a lot of them use stereoscopy. And then at least some sort of minimal motion. So often you'll just have, like a constantly rotating molecule, just so you can, because that enhances the ability to see the relationship between objects. And then especially with VMD, even if you're still at the desktop, they at least have a lot of interfaces for, it used to be space balls, now it's more space navigators, and these sort of desktop devices that let you push forces in all three dimensions, and as well as rotations around all three axes. And then in the late 90s, they actually there were some low-cost haptics devices. We have some actually sitting over here called the Phantom Omni, and that kind of brought haptics down to, university research group level, about $8,000. And so they started installing this, and now you could actually have two molecules interacting, and you could feel some of those forces, some of the ways molecules interact with each other, and so that gives you an even better sense. And then building on motion, if you actually tie that motion to head tracking, which puts you into the realm of virtual reality, then you have just a little bit more. Now, typically in, say, Klaus Scholten's group, they'll mostly be sitting at desktops with stereo and little 3D input devices. But if they have the head tracking, then they'll use it. But for the most part, if you have like a whole lab of 20 people, they're mostly going to be sitting at desktops. And then I was at NCSA at the time, and so Klaus Scholten's group was just one floor above the cave at NCSA. So we started integrating VMD back into the virtual reality realm, also in the late 90s. All right, so some kind of general VMD features. It can handle actually fairly easily up to like 60 million atoms in a simulation output, and it's very good at time varying. That's kind of its strength when you compare it to the other sort of molecule visualization tools, is that it handles time varying playback really well, and I'll show you some of that in a moment. Stereo is really easy. There's a pull down menu. It's got like 18 different stereo choices that you can just, if you brought it up in mono, you don't have to pre-configure it. It'll just start up in stereo. And it also has pretty easy input device for 6 degree of freedom, things like Space Navigator. The VR features, as I said, it's kind of light at the moment. There's really kind of just two, and it's really just to move the molecule around. The first one we had was you bring up a grabber. There's some interfaces. You have to kind of go through some clunky user interfaces. You get a wand pointer, and then you actually have to precisely grab a molecule and move it around. And if there's two molecules, you'll only move one. You won't move the whole world. So recently we've added the ability to kind of navigate through the whole world, and that's what I'm going to show you today. All right, so nothing, earth-shattering here. If we're talking molecules, you have points. Each point has a type, which is what it's colored on, and then they also have things which you'll see in a later demo where they categorize where things are on a protein chain, and they have kind of different functions if they're in different types of chains. And so there's other data associated with it too, as well as just type. And then there's bonds, of course, to connect them. So, like I talked with the RUI applications yesterday, why do you choose a particular VR library? Well, we chose FreeVR because I was writing FreeVR at the time, and so we were working together. Also talked a little bit, I think, yesterday about the fact that, well, maybe not, a lot of times when you take two sort of disparate systems, one that does visualization and the other that does virtual reality, and they were heretofore separate entities, bringing them together is not always, an easy path. See, VMD already has its means of opening windows. It already wants to control, the rendering algorithms. So sometimes when we bring them together, it's a little difficult, and we'll see some results of that in a moment. So at the moment, VMD kind of spawns a separate FreeVR application and sends the data over, but it's not always cleanly done. All right, so let's do some live demonstrations. Oh, let me get my wand over here. All right, like I said, it's pretty light on VR. If you have your glasses on. So head tracking is on, and I can walk around it. Goes on the screens. So now one thing, so here I'll show you a deficiency already. So this is something that sometimes VMD will generally always work great with one screen. But once you go to more than one screen, it sometimes has a little trouble getting some of the data across the screens. Now the molecule, if I walk over here, you see that's actually working pretty well. It's going on the floor. But if you look, there's a set of axes here. And if you watch when it goes on to this other screens, the labels stay there, but the axes themselves are gone. And sometimes if you have bigger molecules, the whole molecule disappears when you go on other screens. So in a couple of the demos, I won't venture onto alternate screens. But anyway, we just really have a couple of things here. I can press the trigger. I guess I have to wake up the wand here. There we go. I can press the trigger, grab it, bring it closer to me. We can actually, it doesn't have a scaling operation yet, other than you can interface with it still with its FLTK interface, and then I can fly around it. All right, so, and that's really all we have right now. But still, a lot of times that's kind of enough for what the molecular community is looking for. They just kind of want to see those relationships and see what's going on. Well, let me quit and I'll show you the name. Otherwise, I don't know. But yeah, I have the other ones. I'm going to switch to another one anyway. So let's see. Oops. Let's see. Quit his. There we go. So that is a bacteriohodopsin molecule. Yeah. All right, so let me show you a couple more molecules that are a little bit more interesting. So this one you'll see I've just put on the front screen, and that's because it consistently wasn't working when I put it on more than one screen. But this shows kind of the time varying ability of VMD. And so this one I don't know exactly what it is, but I can tell you in general what this is basically it's part of like a cell membrane, and it shows you chemicals that are able to work their way through a cell wall. Right? So there's these special sort of pores that only allow particular molecules to actually pass through them, and the molecules kind of have to, it's all from diffusion, right? So it's random. Sometimes they'll go one way and then actually go back the other way. But through diffusion, they'll eventually, if there's more on one side, they'll go the way they're supposed to. Or actually, some of these pores can be one-way pores. Once the molecule gets in there, it can only work its way out. And so this is, these abilities to do these huge simulations. So here's where those residues come in. So these curly things are also, of course, part of the molecule. We're just not representing them in the ball form that we have here. They're just protein chains or carbon chains, and so we're just representing them very simply so that we can concentrate on this channel. And if you have the head tracking on, you can go right into the channel there and see what's going on. All right, and also, of course, the simulation has a lot more going on. There's actually water molecules all over, floating all over the place. We just don't turn them on.
So when is the PVR application rendering VMD?
Right, right. So VMD has this little like 3VR add-on to it that it
So how difficult was it
links to.
in the sense that it just looks like when you render a window manager or
Yeah, there's like a little VR sidecar thing that we wrote, and then some of it got modified while I had left NCSA, and they continued to work on it, and then I came back, recently and enhanced it a little bit more. So I think we're going to do a little bit more, and it'll be even better.
so it's thinking like now
Because of the data, it's updating the data constantly, and we're not like not doing a swap. And we should be waiting to do a swap buffers when the screen refresh is happening. Yeah, so I have one more molecule to show, and then I'll show another feature that we have. Oops, gotta get the mouse over there. Oh. All right. So this next one, I'm going to try to run on all screens, but it may or may not work. Looks like it's not working right now. So here you can see the colors of the main part that we want to see are black, and it's not supposed to be. This actually has 4 channels, kind of similar to what we saw, except this is more of a liquid passing through channel. And we're seeing kind of a cell membrane, outer membrane here, and a cell inner membrane there, and then all the protein structures in the middle. I'm going to restart this. So I wanted to, show all features, good and bad. I'll try it one. Whoops. Oh no, that's not what I wanted. We'll see if it comes up with color this time. No. Huh?
The lighting?
Yeah, well, it's not the. I don't want to do that.
The lines of color numbers just lighting turned off.
Oh, that could be. Yeah. Oh, so that worked on the floor, but not the front screen. I'll give it one more shot, and then we'll just do the front screen. Oops. I keep doing that. Oh, that's a good sign. There we go. So you can see it's kind of random. So we're actually, the main offer of VMD is going to come visit us and help us work through this, because he doesn't have a cave, so he can't test this. He doesn't have like multiple screens running multiple processes. So here's the same thing, except these are water channels. So you can see these little water molecules working their way through the cell membrane. And we've just highlighted 4 of them. There's obviously, lots of them around. And again, there's this special protein chain in the middle here that kind of controls and allows, a specific molecule, in this case water, to pass through. Right. And so one of the things that, in addition to the visualization side, one of the things the molecular computational simulation group does is they actually, they sort of have a starting point where they want to build some sort of simulation. They know more or less what the molecules are like, and they let sort of energy efficiencies let the molecules kind of form themselves out. But sometimes they get a little twisted, and they have to go in and actually say, okay, well, how the computer initially said this is how a protein might shake out based on the energy distribution, it ties itself in some knots. It gets itself into some local minima of energy, or maxima of energy, and so they kind of go and they untwist it. And this is where they kind of want to be able to go in 3D and grab grab atoms and move them around and kind of untwist parts of the simulation, and then run it through the supercomputing molecular simulation. Yes? No, this is stored data. But it can. VMD there's a corresponding program called NAMD, which is a nano molecular dynamics simulator. And so they can actually either link it directly to VMD and you can watch it live, or you can store it and replay it back later. You mean the black? So what I think is happening, yeah. So it's basically any water molecule that hits a certain region, it's deciding to render as a ball, right? And so sometimes a water molecule kind of starts to creep in So there's a whole, there's water on both sides of this. In the simulation, we're only rendering the water molecules that are near the channel. And so yeah, sometimes a water molecule kind of comes near the cell membrane, and it gets turned into a ball, even though it's not part of the march of the water through the pores. Right, yeah. Yep, exactly. And I'm pretty sure that that's what that is. All right, and there is basically one more feature I want to talk about. All right, let's see. All right, so the grabber thing is we're deprecating that, so we're not going to talk about that. But basically, normally you would run VMD and give it a molecule from the protein data bank or something like that, or you can actually run a script. So I'm running scripts right here that have the ability to run these things in. But basically, you just add this display device free VR, or it used to be you could do Cave Library, things like that, and then it'll just kind of work in free VR with the caveats already given. Wrong way. All right, and there's one more feature then that the group is working on. It's not necessarily a virtual reality feature, but they have an Android app at the moment. I don't think they have an iPod one or iPad one or iOS one. And basically, you can bring out your Android phone. You can run this special VMD remote app, and you can then control the rotation. So they actually intend this to be, if you're like in a group setting like this, and some scientist says, wait, I want to see something, over there, and then you can scale it, rotate around, and then if you have a list of people all running the app, there's a little executive that lets you choose who's in control at any given time. And there's one more feature I want to show with this, but I don't want to do it with it. I have it set for the other molecule, so let me go back to the other molecule. And so this actually does have a little tie-in to the VR side of things. So let me go back to the first one we ran. So again, I can rotate this molecule, but they have these 4 little buttons that you can tie little Python or Tickle scripts to, actually. So I can change this to represent, different, let me move that molecule back a bit, different representations. There we go. Whoops. You can choose different representations, whatever you, like I say, there's this huge Tickle and even a Python scripting ability for VMD. It was written before Python existed, so there was a lot of Tickle stuff built in. And you can literally run these huge scripts and just attach them to any of these buttons. I forget what I mapped these ones to. Maybe nothing. All right, I didn't map those. So the tie-in back to FreeVR is one of the other features that I'm hoping that can get added, is that we can take these buttons and map these to little Python scripts and do exactly the same thing. So you don't have, if you're not in the conference room setting where you want to do this, we already have the ability to kind of rotate with the wand, but we don't have the ability to do anything other than we go over to the little menu and we manipulate things, on the desktop style. So I think it'll be good if VMD gets the ability to basically take what they've developed for the Android app and put that into the VR space. All right, and so that's basically it. So anybody can download VMD, although they do have you register. They want to know who's downloading because they tell NSF and the NIH how many downloads have happened. This new navigation stuff is in version 1.92 Alpha 20, and they're probably due to release 1.92 in the near future, but I talked to John, and he's basically, just email him, and he'll build you one. So if you want to run this on Windows, well, can't do FreeVR on Windows, but if you want to run this as a prepackaged thing, then he'll do that for you and just send you a tarball. And so if we do have a VR library that runs on Windows, we could tie that, and maybe someday that'll happen. And so that's basically it for VMD. Oh, you don't need to read that. Yeah. Yeah.
What's the future, what's the future roadmap of the VMD and CVR? Are we going to fix these issues?
Well, it's as John has time. He's, at some point, he may come and give some talks at IU, and I think I can probably grab him for a day and push through some of these things. right? And so John, he's an what do they call it? NVIDIA fellow, which means NVIDIA pays him to go around and promote GPU programming and both on the graphics side and the computational side. So he has money to like go around and travel and visit places, and so I'm hoping to convince him to come to IU, and when he's there, I'll have him and I'll say, fix these things, John. Yeah, Dave.
So, maybe this is a tougher question. It's not a technical question, but you're saying he doesn't have access to a cave, but yet, there's a six-sided.
Well, that's actually a good point.
There's a six-sided.
It is in the South Farms, but yeah, that's a good point. There is a cave on campus, I suppose, yes.
Yeah, I mean, it would have
At Illinois.
worked for him to,
Right, well, it's not a top priority thing for him, right? I mean, the scientists aren't going to go to the Beckman lab, on the other side of campus. And so he's really there to support them and support the VMD user community. But yeah, if a lot of external people were clamoring for VMD in VR, and they could say to the NSF and the NIH, these are important things. We have all these people requiring it. Then he probably could justify his time to go and spend some time at the Beckman Cave.
That's working now.
Yes. See, it's sometimes works. I mean, you saw I ran the other one 4 times before the colors came up, right? It'll always work if it's just on one screen, but once you go multiple screens, then it's kind of hit or miss. All right, so that is VMD, and Dave is up next. Well, this is the first talk that deserves applause.